Okay. Now, the difference quotient is f of x plus delta x minus f of x over delta x. I'm trying to remember exactly how I did this, because I didn't have this written down when I did all this, but I'm not going to think that much. Okay, f of x plus delta x minus f of x over delta x. Now, what does that mean? Well, we just draw a graph to represent any old function. Now, people had an amazing amount of trouble with this, and it surprised me, but then remembering that most of people's experience with graphs consists of graphing calculators, I'm not quite as surprised, but this is something that needs to be fixed. So we spent a lot of time trying to fix this. Okay, so I said, okay, so here's a graph, and then I put 2 points here, x and x plus delta x. Okay, and then I said, okay, where on the graph do you find f of x? And nobody could answer. Okay, well, it should be clear that if this is a graph of y equals f of x, that the coordinates of this point are x, y. Yeah, this is x, so the coordinates of this point should be x, y, so that y should be f of x. Well, if y is f of x, then that's the y coordinate, so this coordinate here should be f of x. Meaning that the height of this line segment should be f of x. Okay, and I didn't explain it that way during the surprise that I got when people couldn't seem to understand this. But we're talking a bunch of really smart people, so I'm confident people will understand this, probably do already. Okay, so anyhow, if this is x, then the y coordinate is the value of x, the value of f of x. So that the height of this segment here is f of x. So when I draw a trapezoid corresponding to what I've got here, here's x, here's the height, here's f of x, there's one of the vertical lines on your trapezoidal graph. Now, if I've got x plus delta x here, then I want to know where f of x plus delta x is. Well, if this point has coordinates x plus delta x, then the y coordinate up here is x plus delta x, y, right? So here's your y coordinate, but of course the y coordinate is what you get when you put x plus delta x in for x, so that's f of x plus delta x. So that from here to here is f of x plus delta x. Now, at the time I did this, I didn't have the green triangle in there, so it might be a little unclear where f of x plus delta x is, but this picture here tells you that f of x plus delta x is this thing, which corresponds to this line from here to here on the graph. So now we have a trapezoid. We know everything we need to know to find the slope and area of the trapezoid. Now we can find the area, but we're not going to do that today. We're just interested in the slope for the moment. So we have altitudes f of x and f of x plus delta x, graph altitudes, okay? And points x and x plus delta x on the axis. So we want to find the slope. We want to label the slope. Now we had to say, okay, well, how do you do slope? People didn't know what to do. Of course, they're a little flummoxed by the picture, okay? But first thing you should think of with slope is rise divided by run. Rise divided by run. So you ask yourself, you break the question of what's the slope down into the slope question of what's the rise and what's the run. So the rise is, well, from here to here. That's at height graph altitude f of x. This is a graph altitude f of x plus delta x. So the rise is this minus this. F of x plus delta x minus f of x. The run, well, that goes from x to x plus delta x. People got that pretty quickly. It's x plus delta x minus x, which simplifies to delta x. So that the rise divided by the run is f of x plus delta x minus f of x divided by delta x. And now we're up to this. Now I remember the order in which I did this, so I didn't have to say this at the beginning, but there is the difference quotient. It's not handed down on a stone tablet. It has a perfectly sensible interpretation as the slope between 2 points on a graph. Okay, so there it is. And then I say, well, what's the meaning of this thing? Well, it's the change in the value of f of x divided by the change in the value of x, because the values of f of x are f of x plus delta x and f of x. So the change corresponds to the rise. The change in the value of f of x corresponds to the rise. So it's the change in y equals f of x, the rise, divided by the run, which is the change in x. Meaning that we can describe this in a simple set of words as the average rate of y, average rate of change of y. I tell people not to leave words out. Now you can't really read it. Average rate of change of y with respect to x on the interval x, x plus delta x. Okay, that's the meaning of the difference quotient, and average rates of change are really important, right? What's the average rate of change of depth with respect to clock time? Okay, it's how fast the water is decreasing, and if your reservoir's going down, you kind of want to know how fast. Okay, so for one reason or another, it's an important quantity. So we went on to an exercise where I again drew a graph, but put a scale on it. So we got this graph here. X is going to be time, and Y is going to be depth. So this is like depth versus clock time. I had T for time, but then I started using X in my variable because that's what I used before, and I had two things going on at once. So I had to just change the T to an X because this is the only place I really used it to. Okay, and one place over there. Okay, anyhow, so we got time running from 0 to 10 to 20, and we have depth running from 0 to 8. So, we'd subdivide this interval in half, we get 4. We divide this in half, and then in half we get 1. So we see where our numbers are. So what we asked was, okay, let's make a sketch for f of x plus delta x minus f of x over delta x for x equals 10 and delta x equals 5. And we found that nobody really understood this completely, even though what we did before, so we had to spend more time on it, and that's okay. It was important time, it was worth it. And I think we got it to where everybody understands it. Okay, so we have, okay, if x is 10 and delta x is 5, then what are we going to do? What picture do we draw? Well, people drew a picture of the trapezoid thing from 5 to 10. People drew 10 and f of 10 but didn't know what else to draw. So we had to stop and work this through. Okay? So I came over to another example just to show how we could approach this. I said, okay, now, this is not a graph of f of x equals x squared, but if it was a graph of f of x equals x squared, what would we do? If x is 10 and delta x is 5, just as it is over here, but instead of this curve, we have f of x equals x squared, can we find f of x plus delta x? Okay, what would that mean? Well, people had trouble with this, but again, we're in the middle of a bunch of confusion. It's not, we've got really smart people here, but well, there's something going on in the curriculum that doesn't prepare people to understand this. Either that or I'm explaining it worse than I think I am. Okay, and both are possible, and some combination thereof. Okay, what is f of x plus delta x? If f of x equals x squared, it's x plus delta x quantity squared. Which means, of course, since x is 10 and delta x is 5, it's x of 10, it's 10 plus 5 squared, which is 15 squared, right? Okay, that's one way we could figure out f of x plus delta x if we had a formula. Now over here we have a graph, we don't have a formula, but there's insight to be gained here. So one way to do this, eventually we're going to have to substitute 10 for x and 5 for delta x and figure out what we've got. Okay? So we substituted here and then we saw what we have. Alternatively, we could have substituted the 10 and the 5 immediately in the expression f of x plus delta x to get f of 10 plus 5, which of course is f of 15. Then, if we know the function, as we do here, we can evaluate it. It'd be 15 squared. 225. That's not important, it's not relevant to the graph, but the point is f of x plus delta x is f of 15. So what we need is f of x plus delta x is f of 15. Same here as it was here, but now we're applying it to this function, which means that we have to come over to 15 and then do f of 15. And f of 15, of course, is just how far it is from here up to the graph. Now we could project that over there, so I did, and I say f of 15 is this value. That could be estimated, and it was supposed to be estimated, and everybody eventually did get their estimates and then got it right from that point on, which is why I'm pretty confident people are okay with this. First, you have to see what the notation means. So you have to see that if you know x and delta x, then to get f of x plus delta x, you got to figure out what x plus delta x is, so you know where to go in the axis here and how, so you can go up to the graph and find the value of f of x plus delta x. Okay? So anyway, we do that, and we get this, and we get this, and now we can estimate this, and we can estimate this value. Now, everybody's graph was a little different, and some people do really tiny graphs and got some pretty funny estimates, but they were okay. They made sense in terms of the graph. So I think everybody was okay with that process. So I do that here. I estimated that this value, f of 15, is 2.6. Here's 1, here's 4. I estimated that's 2.6. And f of 10, well, here's 10. Here's the point in the graph. F of 10, I estimated to be 4.7. Okay? Now, we just write out everything. And this is kind of a lesson on how to write things out too. So here is the whole solution, and here's the picture. There's some labeling up here that you can kind of look at, but we estimated that f of 10 is 4.7, f of 15 is 2.6, so f of x plus delta x minus f of x over delta x is, well, x plus delta x is 15, so it's f of 15 minus f of 10 over 5. We got our values, estimated values for f of 10 and f of 15, so we write them down here, and we do the subtraction and the division. We get this result, and then we slap it down here with a box around it to indicate that's the slope of this segment. And that's all there is to it. Now I got a couple of notations. I say, okay, again, reminding us the rise is f of x plus delta x minus f of x, which we should understand in terms of this. And that would be then f of 15 minus f of 10 for the given values. The run is delta x. So the slope is f of x plus delta x minus f of x over delta x, which is f of 15 minus f of 10 over 5. At that point, we just wrote this down. Okay, but we want to understand all of that. We need to understand every detail of that. And if you think about these a little bit and do them a couple of times, it becomes fairly obvious. Then you have a really good insight into what graphs are telling you. Okay, now we want to do interpretation, because interpretation is extraordinarily important. So we say if y is in centimeters and x is in minutes, what's the meaning of f of x plus delta x minus f of x over delta x for x equals 10 and delta x equals 5? Okay, now people didn't do too awful badly with this. But this whole thing of interpreting meanings is of overworked word, extraordinary importance. Okay? So what does it mean? Well, f of x is a value that we read off on the y-axis. It's a depth, and it's in centimeters. So f of x and f of x plus delta x are depths in centimeters. So, you know, this deep and then this deep. Okay? And delta x is the lapse in time between those depths. So that we can say depth is 4.7 centimeters when the clock reads 10 minutes. This expresses the same thing, now that we have this interpretation, as saying f of 10 equals 4.7, which of course corresponds to the graph. Yes, we got this off of the graph. We didn't have a formula for the function, okay? But we did have the graph. Okay, so that's the meaning of this. So then I asked, what's the meaning of f of 15 equals 2.6? And somebody pretty immediately gave me a really good statement that I liked, which made me feel pretty good for people, you know, because it's important to understand this. Said, well, at 15 minutes, the depth is 2.6 centimeters. Bingo, perfect. So I wrote that down. F of 15 equals 2.6 means at 15 minutes, the depth is 2.6 centimeters. Now, the difference quotient tells you then that the depth changes from 4.7 centimeters to 2.6 centimeters in a time interval of 5 minutes. So you can calculate the difference quotient using those values and using those units. And you know, you would obtain what you do. Okay. Now I did a couple of other things, so I guess I'd better go ahead and summarize that. Yeah, I'm not going to. I don't have the statements. This is for the good of the group. But since we don't have the statements written down here, I'm going to leave it alone for now because we'll come back to these anyway.